Good morning, student. See, today is the 8th class of the chapter relations and functions. Okay, I think the main idea of the chapter you have already got. Now just I am solving the questions. Okay, so today I shall solve only these questions, and after that I shall solve some other questions which are not related to this one. Okay, that means in the next class we shall prove how to prove that an equivalence is not reflexive, not symmetric, not transitive. That means whenever the relations are not reflexive, symmetric, transitive, and after that I shall do one more part, that is equivalence part. Then the chapter will be the part relations will be over. Okay, after that functions will come. So because Saturday will be the last class, after that I shall move to section A and C. Okay, so that you do not face any difficulties when I shall start the chapter once again after some days. Okay, so that's why I shall complete everything of this part relations, then we shall move to the other part. Okay, so let us see. I have written in the question here, class number 8, relations and functions. What is the question? Question number 12 I am showing you. Show that the relations are defined in the set A of all triangles as are equal to T1 comma T2, T1 is similar to T2 is an equivalence relation. That is the question. Okay, so just like the previous cases, here there is a relation and there is a set. What is the name of the set? The name of the set is A, and the set A contains what? The set A contains all triangles which are similar. That means if we can draw lots of triangles here, and if we pick up two triangles from here, that two triangles must be similar, then only the pair will belong to R. ठीक है, तो हम लोगों को क्या करना है, यहाँ पे दो ऐसा ट्राइंगल को पिकअप करना है जो सिमिलर होगा. अगर वो दो ट्राइंगल सिमिलर होगा तब जगह वो पेयर जो बनेगा वो पेयर कहाँ पे होगा? द पेयर विल बी इन R. ओके, सो here we shall prove what? Here we shall prove the reflexivity, we shall prove the symmetry, and we shall prove the transitivity. Okay, because we have to prove that this is an equivalence relation. And already I told that we shall not discuss the second part of the question, because the second part of the question is related to equivalence class. Okay, equivalence class still now I did not take. At a time when I shall teach you equivalence class, all the second parts will be finished. Okay, so let us start with some very simple. You can do it by yourself also. So since we have to prove that the relation is reflexive, that means a particular element will be considered from the set A, and we shall prove that the doublet belongs to the relation. So let since we have to consider a triangle, so let T belongs to A, B arbitrary. I have written only A, R, B, that means it is arbitrary. Okay, now we have to prove that the doublet belongs to the relation R. Okay, now see, just like the previous one sum I have done, that is question number 14. Okay, in the previous video I have given that one exactly of that pattern question. So we know every triangle is similar to itself. Every triangle is similar to itself. We know that every triangle is similar to itself. Okay, that means what we can write? T is similar to T. So we can write T is similar to T. So we can write T is similar to T. Instead of writing T is similar to T in words, we can use this symbol also, because in class 10 also you have got that this is the symbol of similarity. Okay, so T is similar to T, that means these two triangles are similar. Since these two triangles are similar, so the pair belongs to R. Why? Because this is according to the question. So this can be written as T comma T belongs to R. So we consider the element from the set. Now what we have proved, that the doublet belongs to 1. That means it is a reflexive relation. So it is a reflexive relation. So R is reflexive. So R is reflexive. Now we shall prove symmetry. Symmetry. What is the rule of symmetry? You go to the definition. Okay. What is the definition of symmetry? We shall consider a pair. From where? From the relation. And what we shall prove? The doublet belongs to R. Okay. So let T1, T2 belongs to R. Be arbitrary. I have considered that T1, T2 belongs to R. Be arbitrary. Now, since the pair belongs to R, I told you, everything is coming from here. Everything is coming from the question. Since the pair belongs to R, that means the two triangles must be similar. Why? Because this is according to the question. So we can write T1 is similar to T2. Okay, you know the definitions of similar triangles very nicely. In class 10, you have got it. Now, if T1 and T2 are similar, so what you can write? T2 and T1 are also similar. If T1 and T2 are similar, that means T2 and T1 are also similar. So these two triangles T2, T1 are similar. That means the pair belongs to R. So T2, T1 belongs to R. So R is symmetric. R is symmetric. Okay. Now we should prove that R is transitive. You consider the elements according to the definition. Let how to consider the elements to prove the transitivity? Let T1, T2. If we want to prove the transitivity, what we have to do? We have to consider two pairs from the relation. And how to consider the pair? So that the second element of the first pair and first element of the second pair is same. So T1, T2 and T2, T1 and T2, T3 belongs to R. Be arbitrary. So I have considered two pairs from the relation R. Next, since this pair belongs to R, so we can write T1 is similar to T2. This pair also belongs to R, so T2 is similar to T3. So what we are getting, you see, just if you consider the triangle T1, this is T1, this is T2, this is T3. These are the three triangles. These T1 and T2 are similar. T2 and T3 are similar. So these two parts are also similar. Similar means what? Similar means the look is same in general. I am not going to according to the definition of mathematics. Similar means the look is same, but they may be bigger, they may be smaller. Okay, this triangle is same, this triangle is same, look is same. Okay, so they are similar. I am telling you, I am not going to go. I am not going according to the definition of mathematics. Okay, in general, what it is I am telling you. So that means we can, if we combine these two parts, what we can write? T1 is similar to T3. So since T1 and T3 are similar, what we can write? We can write T1, T3 belongs to. So T1, T3. So T1, T3 belongs to R. So R is transitive. R is transitive. So R is an equivalence relation. R is an equivalence. R is an equivalence relation. So this question is completed. Okay, you have seen that I have solved the questions in a very easy way. So some parts I am leaving as your homework. You must complete that one. Question number 12 I have done, question number 10 I have done, question number 9 I have done, question number 8 also I have done. So question number 13, question number 7, question number 15 and 16 are your homework. If you have any problem in these types of questions, you let me know immediately so that I can solve the questions and I can submit it to you. Okay, in the next class, that means still if we go up to Saturday, 2 more classes are left. 2 more classes are left. So I shall solve the questions from the first part. That means I shall solve some questions from question number 1 to 5. Okay, because these questions are a bit different. Here we are not going to prove that the relations are reflexive, symmetric and transitive. Okay, we are going to prove that relations may be reflexive, may be symmetric, may be transitive, but it may not be also. Okay, so the questions will be different than these types of questions. Okay, so I hope that you understood this chapter very nicely. So you solve all the questions so that we can move forward. Okay, thank you.